You developed a Reaction Plan Manager++ solution, and now it's time to test it. You want to make sure that your calculations and your instructions are correct, so the operator is getting the appropriate information to adjust his process. In this video, I'm going to show you how to use some new tools that were added to version 3 that will help you test your logic. I'm going to start by measuring a part and building a solution from scratch. I'm going to use the training CMM to simulate measuring a part on a CMM. I'm going to click on the Inspect button, and it'll send data over to the Reaction Plan Manager++ software. It'll recognize that a solution doesn't exist for this particular simulation, and it built one for us automatically. Now, if I were really developing a solution, I'd go to the Edit mode and set up my data collector. I'm going to click on the data collector, and you'll notice I've got the General tab, the Filter tab, the Configured Data Collection tab. And there's a new tab that's been added called Test. The Test tab is used to actually test your solution. You can run tests on your solution. Now, if I were setting up the data collector, the first thing I would do is set up my filter. So I'll go ahead and do that real quickly. And I'm going to set up a filter to group the data by machine. I'll add that filter, process the data, and that will add a reaction plan, the machine A reaction plan over here on the left-hand side. I'll go ahead and delete the blank reaction plan because we really don't need it anymore. And if I were really writing a solution, I would add the logic in the dimension items and set up my groups and build the detail view. Now, if you're not familiar with how to do this, there are other videos which will lead you through the process. There are three pieces of the solution that you need to test. The first piece is the data collector. You want to make sure that the data collector is reading data from the data source properly and is filtering it. The second piece is the dimension items. You want to make sure that each dimension item is analyzing the measurement data properly and deriving the correct instruction. The third piece is the reaction plan. You want to simulate sending data to the entire reaction plan. This will exercise all the dimension items as well as send data to the links. It'll actually execute the link. So this is how you test the whole reaction plan, is that final piece. Well, we've already taken care of the data collector. I just created this solution, so I know the data collector is properly configured and is pumping data to the appropriate dimension items, or I'm sorry, to the appropriate reaction plans. So I know the filtering part is working. The next step is to test the individual dimension items. Now, there's a nice tool that was added to the editing tool where you can actually include your own data set and run it through the dimension item. So for example, if I click on the 1x, you'll notice there's a test dimension tab. If I click on the test dimension tab, here's where you have access to tools where you can enter your own data. There are two ways you can enter data. You can manually type in the values that relate to the dimension item, or you can incrementally add data to the dimension item. So for the test data, I want to enter in, I know this is I think this is a 4, the nominal is 4 with a plus or minus tolerance of 6. So I'll enter a value of 4.001, for example. Click on Add Data, and it added a data point. If you want to add more than one value, you can separate each value by space or tab So for example, if I want to put in a space here and enter 4.002, if I click on the add data, it'll add these two values to the dimension item. If you want, you can copy and paste from Excel. So for example, I may have a column of data that I have in Excel and I want to just enter it in here. I don't have that up and running, so I'll just simulate that by hitting enter 4.02, enter 4.03, add data, and you can see how that works. If I want to add incrementally, I'll put in a value of 0.001, click on add data, and you can see it added that data point. I went ahead and hit that button a second time, and notice it triggered a percent of tolerance rule violation. And it says adjust tool 1 X offset by minus 0.005. Well, that instruction, the wording looks okay, but the value is not correct. I'd like for it to be half the amount, the correction amount to be half the deviation to nominal. Well, to change that, I have to go to the last run reaction and put in a 0.5 multiplier for the last run correction multiplier. If I go back to my test dimension, you'll see that the correction amount was split in half. So you can see I can bounce back and forth and make sure that the dimension item is calculating things properly and giving you the appropriate instructions. Now the nice thing about this is once you put the data in and you save the changes, the data for the dimension item will be saved with the dimension item. So if I click on the save changes, I'll click on the 1y. You notice there's no data for the 1y. Go back to the 1x, and our test data is still there. So this tool is used to actually test the dimension items. Now we're ready to test our reaction plans by simulating sending data to the solution. To do that, I'll click on the data collector button and we'll go to the test tab in the data collector. There are a variety of ways that you can simulate sending data to the reaction plan. Now, when you execute one of these simulations, it will use the offline plan to show you the information. The first choice is available data. This will actually allow you to run the data collector and pump the data to the offline plan. If I check this where it says execute offline plan using data collector from the data collector and hit the button, it will bring up a window which will allow us to identify how many parts you want to use. You say okay. It takes the data from the table and it pumps it to the offline plan, and then you can look through your results and see what the information, how your dimension items are telling you how to react. That's one way of performing a simulation. Another way is to use the test data. I'm going to clear this. Now, if you're not sure which dimension items have test data, I can click on this button here which says display dimensions with test data, and it'll show you the dimension items that actually include test data. Of course, we only added test data to the 1x. The rest of the dimension items have no data. Now, if I click on execute offline plan using test data, watch what happens. The other dimension items include part data. It's as if you measured parts. And notice the number of parts equates to the number of dimension items that exist within this dimension item. So when you click on that button, it'll look at all of the dimension items that include test data, and it'll figure out how many parts to pump to it. and basically it pads the dimension items so that you can then focus on the dimension items that include test data. That's another way to simulate measuring parts. A third way is to increment by value. So I can put in an incremental value. I'm going to clear the data. I'll put in 0.001 as the incremental value. Whoops. And I'll click on Add Data. Again, notice it'll add a point for each dimension item. Well, since there was no data in the dimension items, the first data point that it added was the nominal value. If I click on Add Data again, you can see how the 0.001 is added to each dimension item. That's another way you can test simulate measuring parts. A third way is to identify a dimension item you want to work on. Say, for example, I want to work on the 1y. I'll put in the name of the dimension, and I'll put in the amount. Click on Add Data. The same thing occurs. The first point that comes in will be at the nominal value. If I click on it again, you'll notice the 1y, the data is incrementing up by 1. The rest of them are staying at the nominal value. If your solution include links and you execute one of these simulations, the links will execute as well, so you can test the logic that you have and your calculations that you have in your link. So if you have a process shift link, or you're actually creating a new dimension item from a link, you can see those values and test to see if your logic works properly or not.